Hi everyone, today I will record a small tutorial to explain how to generate a mesh around a 2D airfoil named NACA0012. So I will begin by opening the software called ICEMCFD, which is a software of ICEM. Okay, it is opened. So the first thing is to import the geometry. So in my case, the coordinates of my geometry are stored in a text file, so I click on formatted point data and I search where I've stored it, so it's naked. Okay, and I do apply. Okay, at the moment I have several points which determine my geometry, and I have to create the whole of my geometry. So I click on this and I named it airfoil, and I click on create a curve from points. So create a curve from points, and I click on each point to create the wanted curve. Be careful that you are limited on the number of points to create a curve, so you have to create another curve, but be careful that it should have the same name. So I create another curve with the same name, and I continue to select each point that I want to pass through. Okay, and I close the geometry. Okay, now I have the whole of my geometry. So the first step is to fix the delimitation of my domain. So I have to create points at a fixed coordinates. The delimitation of the domain, I fixed it at 10 chords in front, 10 chord on the top, 10 chord on the bottom, and 15 on the back. So I have to create the coordinates of my domain. So 10 chords in front, so -10, 0, 0. So I zoom out so that I have created that point. 10 chords on the top, so apply. 10 chords on the bottom, apply. And 15 behind, as the coordinate 0, 0, 0 is at the leading edge. I have to fix x equal to 16 and not 15, and the same with 10. Okay, so now I have created the delimitation points, and now I have to create the wall of my domain that I will call geometry. And I select an arc passing through 3 points, and then the same but with spline passing through points. Okay, now I have the delimitation of my domain. The next step is to create the surface where I want to create the mesh. So I have to specify that I have a surface that I will call fluid, and that surface is specified using created curve. So I have 4 curves, and I said that curves delimitate my surface. If I look the surface and I want a solid display, you see that now I have a surface created. Okay, so now you have everything that you need to create your mesh. So now you select the blocking and the icon create block, and you set that you take the same name as your surface, and you have a 2D planar mesh, so you apply, and it has create a block. If I show you what you have at the moment, I need your pre-mesh, you see that you have a kind of mesh like this, which is not what you want at the moment. So you see that the delimitation of your mesh is not coincident with the delimitation of your domain. So the first step is to associate the delimitation of your mesh with the delimitation of your domain. So to do that, you have a function called associate, and you have to associate your edge, the edge of your blocks, to your curve. So these edges to your curve, and the edges to your curve. Okay, now you have associated. To see if it's well associated, the edge of your blocks should be green. It means that it's well done. Okay, now if you look of the mesh that you have, you see that now the delimitation of your mesh is coincident with the delimitation of your domain. But we didn't take care about the geometry, and that's the next step. So you want a C-grid around your airfoil, so you have to create that C-grid, and you select that you the icon split block and the function or grid block. So you have to select the blocks where you want to create that C-grid. So for example 4, and you set that, and you select also that edge. You'll see that what it does, and you will create, you see that you have a yellow rectangle on the right of your domain. It means that it will create an OR grid in this block and this block. But as you only have one mesh in this block, you will see that your O grid is in fact an OR grid divided by 2, so a C grid. And you select apply, and you see that you have a C grid in your mesh domain. So to see what it does at the moment, we see that you have a C grid, so a mesh which is around a block. The next step is to specify that you have a geometry inside your domain. So I will move the vertex of the blocks to facilitate the next steps. So okay, at the moment you have this, and you want to specify that you have something in your domain, and this thing is this geometry. So as before, you have to have your edges of the block coincident with the curve of your geometry. So to do this, you have to do firstly a split of your blocks to have one blocks to associate. So you select the blocks that you want to split, and you select the edge that you want to cut. So now you have more blocks, and this block is the block that you want to associate. So as before, you use the function associate, and you said that you want to associate these edges to the curve of your geometry. So the edge is in green, it means that it's associated, and the last edge of the block is this one, and that you want to associate with this curve. Okay, now it understands that there is a geometry inside your domain. I will move the vertex of the block at the right position. Okay, this one there, this one there, this one looks okay like this. Okay, I will move the vertex like this. Okay, it looks good. And now if you look at what you have at the moment, you have this. The next step is to specify to the software that you don't want a mesh inside your geometry. So if you look, you have one block inside your geometry, and you just have to delete that block to specify that you don't want a mesh inside. Okay, and if you mesh, you see that now you have nothing inside. To have something more which looks better, you can edit your edges, and you will split the edges to be coincident with the geometry. So you select automatically now, you select the edges that you want to split, and you see that it's already better, but it's not yet okay. So I will move manually, and I will split manually the edges to be perfectly coincident. Okay, it looks better. And if I move the curves and the points, you see that the block has now the same form as the geometry. Okay. The next step is to look at what it looks at the moment, and you see that at the moment there is still some parameters that we should put to have a mesh which begins to look like a good mesh. So the first thing that I will do is to split the blocks around the geometry to have a better control on the grading and on the spacing around the geometry. So what I will do is split the blocks, which blocks I want, so the blocks around my geometry, and I want to cut this edge. So now you have more blocks, and you have blocks around your geometry that will facilitate the refinement of your mesh. So at the moment the form of these blocks are not good, so I will specify that this edge will have the same form as this edge. So I will show you. So edit edge, and I want that the edge that I want to copy the form and the edge that I want to modify the form. So now it looks already better. I will do the same with the rest. So this one is that I want to copy the form and the target edge up. Okay, now it looks already better. Now I have the disposition of the blocks that I want. I have enough blocks to control the geometry, and I have enough blocks to control the spacing and the grading. So if I look what I have at the moment for the mesh, it's not okay. So I will define some parameters. So with this icon you will be able to play with the parameters of your mesh. So for example, if I select this edge, I have lots of parameters with which I can play. So for example, the number of nodes. For example, I want 20 nodes on this. I want a uniform node distribution, and at the moment I will just show you what I have. I say okay, and you see that now I have 20 nodes on this edge with a uniform distribution, and I will do that with all the edges. For this one I want 50. This one 70 looks okay, and this one 20. And now you have something which begin to look like a mesh around an airfoil. The next step is to play on the parameters to have a match which will be good enough to do simulation with it. So the first thing is the computation of the size of the first cells close to the wall. So for that I will use a calculator that I will show you. Okay, so first thing, I specify the free stream velocity that I will fix at 20 meters per second, and I set the air properties at 15 degrees Celsius for lengths of the curd equal to 1 meter, and at the moment I will specify y plus equal to 100. So with these parameters I will be able to compute the wall spacing, so the size of the first cells close to the wall. So here I have 1.5 0.50 millimeters. So with that, I said that on this edge I will not use a uniform distribution but a bigeometric distribution. I will specify the spacing, so it's the spacing that I have computed just before. Spacing 1 or spacing 2, it's specified with this arrow, so the beginning of the arrow is 1 and the end of the arrow is 2, so spacing 2 I specify 0.015. Okay, and I put a grading of 1.1 and I apply. And I said that I want to copy the parameters to all parallel edges. No, I will not do that. I will say that I want to copy the parameters and select the edge. So I want this one, this one, this one, and this one. Okay. So if I pre-mesh, you see that now I have a first cell with a length of 0.0015 meter in the normal direction. So the next step is to look at the transition now. So you see that the transition between this cell and these cells is really bad. Normally you have to respect a ratio between 1.3, 1.5 to have something which will be okay for the simulation. So for this age I said, so no, this one, so for this age it's the we begin. For this age is the target ages, and I said that the spacing of the cells will be the same as the spacing of the cell on the adjacent edge. So this one is the target, and if I do a pre-mesh, you see that now the transition is already better. So the size of these cells is equal to the size of these cells. You do the same for the rest. So this edge is the source, this edge is the target. And this edge is the source, this edge is the target, source, target. And you do a pre-mesh. Yes. And now we have something which begins to be good. I will increase the number of nodes on these edges. Let's say 80. Okay, it's already better. Now I have done the transition on this, and I will look at the transition between these blocks. So the same as before, reference edges is this one, and this one is the target. And this one, I think it will have not enough. I think it will be okay. Okay. I will do pre-mesh. Okay, it's not the same for everything, so I said that I want to copy the parameters of these edges to all parallel edges. Apply. And now I have something which begins to be better. Okay. not enough. I can play also on the grading. I said that I want a grading of a ratio of 1.3. Apply. Okay. So for the rest I will only do it for the upper side, but as it's symmetrical you will just have to do it for the lower side. So you see that the transition between this and this is not really good, and even with this. So what you can do is increase the size of this block to have something which is better. So to do that, you can move these edges there. Normally it should be already better. Okay, it's better, but it's not yet good. Okay. Move this. Okay, now it looks good, the transitions are good. Okay, but you see that about the orthogonality in this region we are not really good. So to do that you will use spline instead of straight line for the form of your blocks edges. So to do that you will edit your edges and you will use control point. So for that, see that you can modify the form of your edges as something which will help for the orthogonality. There is also a problem, so here it's not orthogonal with the wall, so I will move it more there, this one more there. You see that in terms of orthogonality it should be better, and if I do the pre-mesh, you see that now there is no more a problem of orthogonality in the region. I should do the same lower, but you can redo it by yourself. Okay, it begins to be well, so now I have looked at the transition between these blocks, at their orthogonality, and at the computation of the first cell size with a y plus fixed to 100. So the last things that I can show is the transition between these blocks. So to do that, this one, I can select, I have 80 and the size of one cell is 0.012. This is the target. No, this is just reference age, and this is the target, and I want the same spacing, so I will have to put more loads. I will say 100. Apply. Pre-mesh. Okay, it's okay there, but it's not okay on the top, I think. There is a problem here. parameters because it will copy the parameters of the edge that I have already done. And I want that here the same spacing, so the source and the target. Apply. Okay, and if I do the pre-mesh, it should be better. Okay, it's already better. Okay, so for the upper part it's done. I can maybe increase the number of nodes to have something which looks better, but it's okay. I think it looks okay at the moment, and it's quite repetitive. You just have to respect the transition, so you have to move the vertex of your blocks and play with the grading and the spacing, and you will have something which looks okay at the end. So I will finish with this tutorial. I think I have shown everything which you will need to do a mesh around an airfoil. Thanks for your listening, and bye.